Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at lesson 8.2. This is called classifying angles. And we're going to just dig a little bit deeper into our angle measures and learn more about angles. So if you look around, you will see angles everywhere. Angles are important in construction, sports, and art. In the previous lesson, you learned how to measure angles using a protractor. Today, you will classify angles and use your protractor to identify special angles. So in geometry, an angle is formed by two rays. Right? You got two rays. Here's one of them right there, and here's one of them right there that have a common endpoint. And I would kind of state it's more of a starting point than an endpoint, because it is an endpoint. But when you think of a ray like a sun ray or a flashlight or something like that, it starts here and then it goes on forever in one direction. So unlike a line that goes forever in both directions, or a line segment that has two endpoints, the ray definitely goes in this direction, so I'm going to call that a starting point instead of an endpoint. So a ray is a line that has a starting point and extends infinitely in a particular direction. The point where the two rays intersect is called the vertex. So right there is both of them start at the same starting point. So one of the most common angles is a right angle. The right angles, as you know, measure 90 degrees. If an angle is less than 90 degrees, we call that acute, and if it is more than 90 degrees, we call it obtuse. So yeah, more than 90 or less than 180. So yeah, we have our limits to our obtuse angles. It's got to be less than 180, but more than 90. So using a protractor, how we would measure angles is every protractor has what's called an origin. That's this point right here. Okay, get out of there. We don't need you to be on there. Okay, and so you want to place the origin right on the vertex of your angle, and you want to have one of your rays go to 0. So make sure that that lines up perfectly with 0. You got both of those lined up, and so now that you've got that, let me see if this guy, how this works. If you measure to right here with this tool, oh, really? Seriously? You're going to, so it's like a 50-degree angle, right? So you can use our little gizmo here, but you don't have that when you use a regular protractor. So just read it. You know, you start at 0, 10, 20, 30, 40, 50. That's a 50-degree angle. And so what we need to do here is we need to measure each one of these angles. So we're going to classify them as either acute, obtuse, or right. Then we're going to measure them in degrees. And so one of the reasons why you want to classify them is when you recognize this is acute, you know you've got to use this number line, because your measure's got to be the number that's less than 90 degrees. If it was an obtuse angle, you'd want to use the outer one, or the one that gets you above 90 degrees, so like the 130-degree mark, if the angle was like this. All right, so take a little bit of time. You can, if you don't have a protractor handy, just use your estimation skills that we did yesterday. You should be able to get relatively close. The most important part is identifying whether it's acute, obtuse, or right, and then if you are estimating, and just try and get within 5 degrees of the answer. Okay, and then problem D says a straight angle, draw a straight angle and measure that. What would the number of degrees be? Go ahead and take a little time working on that. All right, first of all, let's bring this guy down. Let's rotate it so that the vertex stays with the origin, but then it lines up. So this looks like it's going to be about a 30, probably you might have estimated that between 30 and 40 degrees. I'm going to say it's a 35-degree angle, and it's definitely acute. Okay, this guy right here, we could choose to either go this direction and measure that as about 122 degrees, or I can always keep the origin there and go in this direction, and it's still going to be about 121, 122 degrees, and it's obviously an obtuse angle. I guess 120 is what I called it. And then this guy, let's go ahead and match this up. We kind of know what this is already, right? That's pretty much a 90-degree angle, which makes it a right angle. There you go. And then what is a straight angle? Well, a straight angle is the same as a straight line, and all straight angles, all straight lines, really wouldn't matter which point you use for the vertex, it's going to be 180 degrees. Okay? All right. All right, this is a stoplight problem, which means students are making mistakes. So the diagrams below show some students' use of protractors. Explain what each student needs to do to find the correct angle measure. All right, so I may not have chosen the right language here. If you either choose what they have to do to get it in the right spot or write down what it is that they did wrong, kind of that would imply what they need to do to make it right. Okay, so the angles are in blue. This is the protractor. What should they have done? What did they do wrong? Go ahead and spend a little bit of time. Each one of these has a mistake that's been made. Okay, so go ahead and see if you can jot down in a sentence what each one of those mistakes are and what they need to do to correct them. All right, so first one, remember the vertex of your protractor is this point right here. And so you're supposed to place that on the well, actually, no, that's the origin, isn't it? The origin of your protractor is right there, so the vertex is supposed to be on the origin, and it isn't. So the solution is move your protractor so that the origin will be on top of the vertex. Then you can get a true measurement. Here, they've done all right with the vertex. It's just you've got to line up one of these rays with 0 on the number line. And neither one of them are. So you would want to rotate your protractor so that you line up this line with either this ray or you line up this line with that ray. But the vertex is good, so that's wonderful. Here, you've got an issue once again with the vertex. That's not the origin. This would be the origin right there. So you'd want to slide that protractor up. And you can also see that this ray is not lined up with the 0, it's lined up with the 10. So I guess both of those would be taken care of if you just slid the protractor up. And then here, everything is wonderful. I like the fact that the origin and the vertex line up. I like the fact that this lines up with 0. And now we go ahead and we read the measure. But that's a problem because this is not an acute angle, it's an obtuse angle. So you simply read the wrong number. It should have been 120, not 60. So you're using the number line that is on the inside that takes you to 120 instead of on the outside that took you to 60. All right, so we've got two vocabulary terms here. We've got complementary angles and supplementary angles. And I'll tell you right now, in higher levels of geometry, we work with supplementary angles much, much more than complementary. But there are occasions where we work with complementary angles as well. Complementary angles are when you've got two angles that when you put them together, they form a right angle. Okay, so for instance, if I were to create another ray out of this point and turned this, oops, stop it. Come on, you're going to do it for me? That right there. Yes. Okay. So that forms a right angle, right? So that would make these two angles here, which are both acute. When you add them together, they form the right angle. That would make them complementary. Okay. If I were to take this guy now and move it over to here, actually, hold on. Let me just get you out of there. Start with a fresh one like this guy. If I were to put a line right there, now you've got two angles, this one and this one, together. They make supplementary angles, right? Because I don't know what the measure of this is, and I don't know what the measure of that is yet, but I do know that the two of them combined equal 180. So once I know one of them, I can always figure out the other by using some algebraic reasoning. So here's your task. Measure each one of those, or at least estimate the measure of them, and then decide which ones, when you put them together, would give you complementary angles, and which ones, when you put them together, would give you supplementary angles. Go ahead and take a little time and figure that out. Where are you, little? There you are. All right, let's see what we got. So this one is definitely an obtuse angle, right? And I figure it was about 127 degrees. Let's go ahead and line up our origin with our number 0. Yeah, it's about 127, a little bit more than 125. This one is definitely acute. And I estimated it to be around 53 degrees. Let's check that. Does that look like it's about 53 degrees? Yes, it does. And this one is definitely acute, and I estimated that to be about 37 degrees. Let's go ahead, put on our origin. Just rotate this guy to here. And yeah, somewhere around 37 degrees. So which ones are supplementary? Well, the ones that add up to 180 degrees would be supplementary, and which ones are complementary? The ones that add up to 90 degrees would be complementary. So I believe 127 and 53 add up to 180, and 53 and 37 add up to 90. So angle A and angle B will be the supplementary angles because they, when combined, add up to 180 degrees. And then angles B and C are going to be the complementary angles because 53 and 37 add together to give you 90. All right, now, intersecting lines. Anytime you get two lines that intersect, there's always one single point where they intersect, okay? That point becomes a vertex for 4 different angles. You've got, here's your intersection point. You got an angle here, and an angle here. You got an angle here, and you've got an angle there. Now, notice that I have chosen to create one kind of an arc here for these angles and 2 arcs here for these 2 angles. There is a reason for that, okay? The reason is, and I'm wondering if I'm getting ahead of myself. I guess I'll just tell you right now. Whenever 2 angles, or I'm sorry, 2 lines intersect, 4 angles are created. Angles that are across from each other are called vertical angles. The angles that are next to each other are called adjacent angles. Okay, so that's the next 2. Now, in order for 2 angles to be adjacent, they have to have a common shared side. So there's the shared side between these 2 angles. Here is the shared side between those 2 angles, and so on and so forth. They have to have a common vertex, right? There's the common vertex for these 2 adjacent angles. And they have no prior points in common. No overlap is permitted. So we're going to see some situations happening down here. And we have to determine, are we talking about angle 1 and angle 2 being adjacent to each other or not adjacent to each other? Okay, so once again, they have to have a common vertex, they have to have a shared side, shared ray, and there can't be any overlap between them. So if you look at this guy right here, this absolutely qualifies as adjacent angles. They are right next to each other. These 2, however, do not have a common vertex. So they cannot be considered adjacent angles. So the answer to that would be no. This one, there is an overlap. Angle 2 includes part of angle 1. So the fact that there's an overlap happening there means that these 2 are not considered adjacent angles. But I want to be clear. If I said this angle right here is angle 3, then angle 1 and angle 3 would be adjacent to each other because they would share a vertex. They would have that common side there, that ray right there, and there's no overlapping. Angle 1 and angle 3 and angle 1 are completely separate, where angle 2 is the sum of both of those angles. So in this case, it is not adjacent angles because we're not talking about angle 3. We're talking about angle 1 and angle 2. There's overlap happening. Okay. Go ahead and see if you can figure out D, E, F, G, H, and I now, based on what I've shown you and what we've read up here. All right, so taking a look at angle 1 and angle 2, they do not share a vertex, so they are not adjacent. These do share a vertex and a common side, and there's no overlap, so those are adjacent to each other. Angle 1, if we were to say angle 1 and call this angle 3, angle 1 and angle 3 are adjacent, angle 3 and angle 2 are adjacent, but angle 1 and angle 2 are not adjacent to each other because they do not share a common ray for a side. Angle 1 and angle 2 are not adjacent. They're actually vertical angles. They're across from each other. So those are no. These are a no because they don't share the same vertex. And yeah, those two are adjacent to each other. They share a vertex, they have a common line between them, and there's no overlap. So there you go. A, E, and I are all examples of adjacent angles. The rest of them are not. Now for the vertical angles. The vertical angles are the angles that are across from each other, okay? And so when you look at them, I think you might be able to pick up on this. Notice how every time two lines intersect each other, unless those lines are perpendicular to each other, because you will have that sometimes. You got this line here, stop it. You got this line here, and this line right there. Those two intersect each other, and they form right angles because they're perpendicular to each other, 4 right angles. But as long as there isn't a perpendicular intersection, you're always going to get 2 angles that are obtuse and 2 angles that are acute. Well, what do you notice about these angles here? Besides the fact that they're both obtuse, you might have noticed that they're vertical. Wait, what can you say about angles? No, wait, that's not the right thing. Oh, I see. I'm sorry. It's saying right here that angles 1 and angle 2 are vertical. Well, so are 3 and 4. Okay. They're also both obtuse. And when we want to measure those, what are we noticing about the measures? Well, let's go ahead and pull out a protractor and see if we can figure this out. This guy, ooh, maybe I should shrink this down a little bit. Shrink this guy down a little bit. This angle 3 looks to be about 147 degrees, and then angle, stop it. Do I want to do this? Yes. Looks like this one also is about 100. Wait, what was that? I didn't have the vertex in the right spot. Origin, meet vertex. All right, so that looks like it's 155 degrees. No, it doesn't. I'm breaking my own rules. There we go. Yeah, it's about 147 degrees. So now let's rotate this guy around to here. And I know it's upside down, but that's also about 147 degrees. So what's the point that we're trying to make here? They look like they're the same measure because they are. Vertical angles always have the same measure, no matter what. It's always going to happen. Here you can see it 90 degrees, 90 degrees, 90 degrees, 90 degrees. So vertical angles, whenever two lines intersect each other, are always going to have the same measure. So it says here, draw a pair of vertical angles on your paper. Each team member should draw angles with different measures. Measure your vertical angles. What do you think is true about the measures of vertical angles? Okay, so just do this a couple times. Take a ruler, if you've got one, and draw just a couple of lines that form angles, right? You're going to have your vertical angles. This guy is vertical to that guy. This guy is vertical to that guy. Now use your protractor and measure those angles. What do you notice every single time? Go ahead and test that, and then come back when you're ready for the review. All right, let's see how you did. Did you notice that they're always congruent to each other? This word congruent in geometry means equal. So in regular math and in algebra, we say this is equal to that. In geometry, we'd say this is congruent to that. It just means that they have the same measure. Okay, so this is a very important concept to understand about intersecting lines and the vertical angles created. Vertical angles are always congruent to each other. The yellow angle and the yellow angle, they have the same measure, that they're both obtuse angles. These two have the same measure, they're both acute angles. All right, so let's find the measure of the missing angles. Go ahead, copy down these diagrams, copy down the known information, and your task in each one of these situations is to determine what is the measure of angle 2. Okay, take some time and work through that. All right, let's see how you did. These two angles are what you would refer to as supplementary angles. They are adjacent angles, and the two of them combined make a straight line. So that means that we will say that they add up to 180 degrees. So we take the measure of angle 2 plus the measure of angle 1, which we know is 75. That's going to equal 180. So let's just think of this as a variable. And if we subtract 75 from each side, we're going to get 105 degrees. So the measure of angle 2 has to be 105 degrees. Okay, so that M there, anytime you see the M, that means they're referring to the measure, the number of degrees. 105 degrees it is. These two angles are vertical angles, which means angle 1 and angle 2 are equal to each other. So you should notice that if that's 55, then angle 2 also has to be 55. For C, angle 1 and 2 are complementary, which means that when you take the measure of angle 2 and you add it to the measure of angle 1, they're going to add up to 90 degrees now instead of 180. So if you subtract 27 degrees from each side, use a little bit of algebraic reasoning there, you are going to get the measure of angle 2 is going to be, what is that, about 53? No, 63. 63 degrees. There you go. And it says here that they are supplementary. So I guess supplementary angles don't necessarily have to be together and be adjacent to each other. It's just these two angles add up to 180 degrees. So what do you add to 30 to give you 180? 150. So angle 2 must be 150 degrees. Now, I do want to state something about CPM. They are notorious, this math program, for drawing diagrams where the angle measures that they tell you aren't actually the true angle measures. Like if I measure this angle, I'm going to be really surprised if this happens to be 55 degrees. It could be. Sometimes they surprise me. But let me take, there's my origin. Let's actually go in this direction. Does that look pretty straight on the origin? It's about 55. Yeah, it's pretty close, 52, 53. But a lot of times they're way off. Let me see what this one is. There's my origin. Yeah, I guess they're pretty close in these cases. But just a fair warning, don't solve these problems by using your protractor. Use the rules that you've been taught. And don't use your estimation either. Use the rules, because there are going to be some times when they show you what looks like an obtuse angle, but based on the equation or expression that they've given you, it'll actually measure less than 90 degrees and it won't make any sense. But you just have to work with it. Just go with the information they provided and use your strategies, not your protractor or your estimation skills. All right, now we get to a really fun problem. Please pause this right now and copy down exactly what you see, okay? I'll pause and take a little break too. And our goal is to take the known information that we have here and what we've learned so far and see if we can't figure out all of the other measures of all of these other angles, okay? Take a couple minutes to copy this down. What they're not telling you right now, just make sure that these two lines are parallel. They should have given you this little notation here to show you that this is parallel to this guy right here. I didn't draw that very well. So, but it looks like they're parallel, so yeah, they're parallel. All right. Are you waiting for me to walk you through this? Because if you can figure out any of these measures, go ahead and figure those out. Don't just wait for me to do the reveal and you copy them down, okay? Do I need to give you a couple more minutes to pause to make sure that you fill in as many as you can? I think you'd be surprised. In fact, let's go ahead and start with F right here. We know that F and 50 are vertical angles of this intersection, so they have to be equal to each other. So F has to be 50 degrees. And G is vertical to 60, so that has to be 60 degrees, okay? So now that I've got you started, take a walk around and see which ones you can figure out, and then unpause, and then we'll do the reveal. All right, did you get most of them? I'm wondering if maybe angles A and C might have been the hardest ones, okay? So let's finish this process here. We know that 50 and 50 are these two angles, and since E and F are adjacent angles that form a straight line, they must be supplementary to each other. So that means that this guy, if this is 50 degrees, this guy has to be 130 degrees because they added together make 180 degrees. So angle E must be 130 degrees. And angle I is vertical to that. So angle I has to also be 130 degrees. Now let's take a look over here. 60 and G is 60 right there. And these two are supplementary, so this one has to be 120 degrees, which means this one has to be 120 degrees because those two are vertical. Now notice, 60 and 120 make 180. 120 and 60 make 180. 60 and 120 make 180. 120 and 60 make 180. So you've got those four sets of supplementary angles forming the straight line that are supplementary to help justify the fact that the vertical angles have to be congruent to each other. So what did we say there? We just identified G was 60, we identified H was 120, and J has to be 120. All right, let's take a walk up here. You might think that it's kind of hard to figure out what these two are because, you know, all three of these, this 50-degree angle, this angle here, this angle here, have to all add up to 180. But if you don't know which this one, you're not going to know what that one is. So I'm going to come to A. 50 and 60 make 110. What do you add to 110 degrees to give you 180 degrees? That's supposed to be an equal sign, by the way, there. That has to be 70, right? 50 and 70 make 120, and 120 and 60 make 180. So angle A has to be a 70-degree angle. And if you look at these two lines, they are intersecting lines. A would be vertical to C, which means C has to be also 70 degrees. And 60 and B are vertical to each other, which makes that 60 degrees. And if that's the case, this is 60 degrees, then these three should add up to 180. 110 plus 70 is definitely 180. So all three of those are supplementary to each other, adding up to 180, which means all three of these have to as well. But we don't necessarily have to go there because we see that angle D is vertical to this 50-degree angle, so this one must be 50 degrees as well. So this is a big part of high school geometry, is where you learn all these different rules, and you're given a diagram, and you're given one piece to the puzzle, and you have to work through all the rules to determine, okay, what are all these other pieces to the puzzle? And so today we learned about vertical angles, adjacent angles, and the difference between complementary and supplementary angles. And just by learning about those, we learn how to figure out all the measures of these missing angles when we were only given 1, 2, 3, 4. We were able to figure out the rest of them. Alrighty, so that ends today's lesson about classifying angles. Let's move on to the next activity. Take care. Bye.
Hey, feeling good.